everyone. In the last class I covered electrostatic potential energy. Now in this class I will cover the concept of electrostatic potential. We have done earlier that the region around any charge in which other charged particles experience force, we call it electric field. So there are, in a way, two quantities which describe a region in which the charged particles experience force. One we have done, electric field intensity, and the other one is electric potential. So field electric field and electric potential. These two quantities can describe a region in which the charged particles experience force. Electric field is a vector quantity, electric potential is a scalar quantity. Electric field is described by field I mean field intensity. It is described by the force experienced per unit charge. So force by any charged particle, it depends on both the charges, the source charge as well as the charge that we are using, test charge. But test charge is kept small, and electric field we take it as the force per unit charge. So we divide it by the source charge. So now it is a property of the source charge only. So field is force per unit charge. This is how we define the field intensity. Potential is related to the work done, to the potential energy. Force per unit charge is field intensity, or energy per unit charge, it will be taken as a potential. So we will find out the electrostatic potential energy of the source charge and the test charge and divided by the test charge. That is the electric potential at that point. For this we found first the force experienced by the test charge, divided it by the charge. For electric potential we will find out the potential energy for the test charge and divide it by the test charge. Now in the last class we have done the potential energy concept. If this is a charge Q and I have a charge Q2 which is taken from a point 1 to point 2, and the distance is R1 to R2, then how much work? Or we have also done the potential energy U2 minus U1. It was 1 upon 4 pi epsilon naught. Q1, Q2, 1 upon R2 minus 1 upon R1. This is the change in potential energy in taking a charge from A to B. Now this charge, if I divide it by, or you can say if I take it test charge, then the work done per unit charge, change in potential per unit charge, this will be taken as the difference in electrostatic potential. So potential difference is defined as the electrostatic potential energy difference per unit charge. So for this it will be 1 by 4 pi epsilon naught Q1 1 by R2 minus 1 by R1. So if I am taking this as fixed charge Q1 and Q2 I am using as a test charge, I am moving it from point A to B. So the work done per unit charge, so I calculate the work done in moving this Q2 divided by Q2, the difference in potential energy, and per unit charge, that give me the difference in electrostatic potential. And again, if I want the potential at a point, we have to use almost the same concept which we used in electrostatic potential energy. We have chosen there a reference point, the same will be taken here, the same reference point. So I can say, see the potential energy, how we defined it there. We defined it as the work done in moving the charges from infinity to their present position, which is r distance apart. For potential, I will take it work done in moving unit positive charge from infinity to that point. Now here also, if I take the potential 0 at infinity, then the potential at any point is the work done in moving unit charge from infinity to that point. Potential energy is the work done in moving the charges from infinity to their present position. When we divide it by that charge, this becomes the potential. So potential due to a point charge will be 1 by 4 pi epsilon naught q by r. Potential, it is for unit charge. So q is the charge, source charge, and this is the potential. For any charge, q at distance r. And it means that this is the work done in moving charge, unit charge, from infinity to this point. Derivation to be done exactly in the same way as we have done for the potential energy. The only difference is that this charge needs to be unity, or we need to divide the potential energy by this charge q2. Now potential is work done per unit charge. Potential difference between 2 points is work done in moving from 1 to 2 divided by charge. Scalar quantity, what will be the unit? Joules per coulomb. We can find out its dimensional formula. Joule will be force into distance, ml2t minus 2, q will be 80, and we can work out the dimensional formula also. It is measured in joule per coulomb, is also called volts. So that's all about the potential due to a point charge.